Hi guys, today I would like to discuss measuring methods, especially in measuring methods. Let's try to learn how to measure lengths. So these lengths we will try to measure from small to big. I would like to toss a question to you. The question is, what is the least length you can measure by using meter scale? The question, by using a scale, what is the least length? Least length we can measure. So if you can notice carefully in the meters, this meter scale having this particular portion we can take as 1 centimeter. So the least length I can measure, so 1/10 of 1 centimeter, that equal to 1 by 10 centimeter, which also equal to 0.1 centimeter. So this is the least length we can measure by using meter scale. Now what about if you want to measure a length of 0.05 centimeter? What you can use it? So in that case, we will use an instrument name called as vernier calipers. So this is an instrument, its name is vernier calipers. So vernier calipers is an instrument which used to measure length with an accuracy of 0.05 centimeter, with an accuracy of that ones. Okay, so right now I don't discuss anything about this instrument on now, so we need to do certain practicals. So in the practical we will understand how to proceed, how to use this vernier calipers. Now let me ask a question. What if used to measure a length or a diameter of an accuracy 0.025 centimeter? So the length which is smaller than the above case, so these lengths we are using by using a vernier calipers. But the vernier calipers is also having certain limitations. So the smallest the diameter than that, or if you want to measure the thickness of a paper, take a paper, so you want to measure this thickness of this paper, how we can use, how we can measure? So to measure that small thickness or the diameter, so we are using an instrument name called as screw gauge. So its name is screw gauge. So this experiment or this instrument also I don't discuss anything right now. So to measure smaller than the zero point 0.1 centimeters. So for the 0.1 centimeter we used to scale. For the 0.05 centimeters we used to vernier calipers. For the 0.025 centimeters we are using screw gauge. So these experiments we will do on the course of time, so we will get direct knowledge. Now I want to measure large distances, means to measure large distance. To measure large distances, suppose up to certain kilometers, certain meters, up to certain meters, suppose if you can take 30 to 40 meter, so this much we are using tape. So a meter tape we can use it. More than that we won't get it. So by repeating this process same, so up to certain kilometers we can measure certain kilometers by using an instrument meter. Or suppose if you want to measure around 1,000 kilometers at once, if you want to measure 1,000 kilometers at once, so we need to follow certain measuring methods. So here we need to follow certain measuring methods. So at here I'm introducing one of your known knowledge. Suppose if you remember, this is the one of the question from your class 10th, heights and distance. So by using trigonometry, we are easy to find out the what is the height of the post if you know the angle, or if you know the height or if you know the angle. So what is the distance between the observer and the post? So here trigonometry helps us, especially we were using tan theta. By using tan theta, so it is easy to measure. So here trigonometry is a help us. But now comes to the real task. Now think about how, suppose if anybody says the distance of the planet from Earth to Jupiter, we are having certain distances, or we know that the distance from the stars, so all nearby stars, and we are having certain numbers accurately, so the distance of the far away galaxies. So ask yourself a question, how did they measure? How did measure planet distance or stars distance? How did they measure? So to measure these ones, we need to follow certain measuring technique or measuring method. So this is the measuring method we are following. So that method we known as parallax method. Parallax is one of the measuring method to observe far away planets or the stars up to certain distance. So it's not very complicated method. Just do an exercise like this. Stretch your thumb and hold a pencil, and just close your one of your left eye and observe the pencil. Now if you close your right eye, again observe the pencil. And if you can do this action, like this, you will observe there is a shift in the position of the pencil with respect to background. There is a shift in the position of the pencil, which one you hold in your hand, with respect to background. Now that only we termed as parallax method. So the same technique we are going to use to measure the nearby stars or the nearby planets. Let me explain this parallax method much more clearly. So this trigonometric parallax method works like this. So take a background, stretch your thumb. Now close your left eye and now close your right eye. If you can do this action by closing your left eye or by closing your right eye, so if we can observe there is a relative shift. There is a relative shift of thumb with respect to background. Now, this relative shift of the position of the thumb is also works same if you want to observe a nearby star. Suppose if this is the nearby star, I would like to observe from the planet Earth. So if you can apply the same method, there is some complication will be observed because there won't be any change in the position of the star. If you are directly observing at the two position of the planet Earth, suppose if I observe at this side and at this side, so the position of the star from the two different locations of the Earth, so this star shift, it won't occur, no shift. Even if you are observing at the two different locations from the Earth itself only, the position of the star, it won't change at all. So to avoid that, so what we do at here, so we will observe the position of the star with a 6 months gap. Suppose first I would like to locate this star distance from the Earth. That is my task. I would like to know the distance from this star from the Earth. So in the month of the June, if I observe this star location, and after 6 months, the Earth position will be changes, and this is the location of the Earth. And if I would like to locate the position of the star at here, now here you understand it carefully. Now if you can take this as a triangle, so a b c is one of the triangulate form, and this distance, the distance from the Earth to Sun, is calling 1 astronomical unit. Now if I take the total distance, it becomes, that is 1 plus 1, it is the total 2 astronomical distance is the AC. Here the AC equal to 2 astronomical units. So that knowledge we already having. The distance from the Earth to Sun is known as astronomical unit. Now to find the length AB equal to how much? If I know able to angle of this, if I can able to calculate this angle, and we will use that angle by using the formula. So theta equal to arc length by radius, arc length upon radius. So here arc length is nothing but the AB, and the radius is, sorry, here the arc length is nothing but AC and the radius is nothing but AB. So in the place of arc length, so this is the arc length. AC I can substitute it, that value I already know it, and the radius is means nothing but the distance AB. So if you can able to calculate theta equal to how much, that is AC upon AB. Now it is easy to locate the position of the star with respect to Earth. So to calculate the theta, so we need to take the help of a star which is known as fixed star. So this is what it looks like. So to locate a nearby star, suppose I want to locate that nearby star, that is my task, nearby star. We need to observe the position of the star at the two different time period. So if you observe in the month of August at here, so after 6 months the position of the earth will be changes. So from here in the month of the February, so we need to locate this star. Now our task is to find, since we know this distance, so this distance is nothing but 1 astronomical unit, and here we need to find it out this angle known as parallax angle. So how we find that parallax angle? So to find out the parallax angle, so this diagram is helpful for us. So the same diagram, to locate the nearby star, so here these two stars which we have taken on the background, so these stars are fixed star. What about this fixed star? So this statement is really something unbelievable. Why? Because in the universe no star is at rest. It cannot be fixed. It always moving. But think about like this. Suppose you are traveling in a car. You are observing an electrical post. That electrical post is moving with respect to you very fast. Suppose when you cross the electric post, so you feel that the electric post will be move back. But at the same time, if you observe a hill or a mountain which is far away, now if you observe the same situation again, the change in position of the electric post and the change in position of the mountain, how do you feel? We feel that the electric post will move faster than the mountain which is far away. So almost all we feel that the mountains which are far away, they are not at all moving. Yeah, with respect to that position, we feel that. So exactly the same thing happens. Suppose if you select a far away star, so these stars are the fixed star. So they are very important to understand. Sorry, to find out the location of the nearby stars. They are the very helpful. So with the help of the fixed star, so we would like to find out the nearby stars. Suppose if I draw the same, so this is the planet orbit. So in this orbit, suppose if I take the sun is at center, so this is the sun, and at here I am observing at point A, and after 6 months from at point B I am observing a star which is located at here. So this I need to observe. So for that, I am taking a help from at here, a far away star. So this star, if I can take as an S dash, and I need to find the angles at here. So in the meantime, I will find that angles of at there. Now, if you can take the same angles from this side, if you can observe from the location of the B from the star. So this is the star. I need to find out N. N is my star. But the fixed star, which is at background, so that won't change at all. So the location of the background star will remain same. Now what I feel that, so this background star, if you can observe from A, the S dash position remains there only, and if you can observe from the B also, the S dash position same only. Now here the trigonometry helps us. Suppose if you can take this angle is the theta 1 and this angle is theta 2. If you can add these two angles with respect to at there, now here if you can make the corresponding angles, now this angle also, these two are the alternating angles. This angle also becomes theta 1 and this angle also becomes theta 2. Now the total angle, so here the total angle we need to find, so that is the theta. So theta equal to theta 1 plus theta 2. And this angle, how did you locate? The theta 1 and theta 2 angle we located with the help of a fixed star, which is a background star. So this is the theta 1 and theta 2 angles. So by using trigonometry, so these two angles obviously same at here. So the total angle we are representing as theta, which is known as a parallax angle. So that is the theta. Now finally we can find out that what is the arc length. Suppose from A to D, A to B. Now if you can draw the triangle separately, the triangle N A B. So this is the angle theta and this is the distance. We need to find it out, the position of the star with respect to sun, and A to B is nothing but 2 astronomical units, because from the sun the distance from the earth equal to 1 astronomical unit. So from here also 1 astronomical unit. The total distance from here to here goes to 2 astronomical units. So we know that from angle theta equal to arc length by radius, arc length upon radius. So here we need to find radius, means an. So theta equal to arc length. I can take that arc length equal to AB. Here the radius equal to A to N. Now we can find it out an. So theta equal to AB value equal to 2 astronomical units and an equal to D, and the D equal to 2 astronomical units upon theta. So we can convert that in terms of the radians. So finally we can figure it out, the distance. So this is the distance nearby star. So this method is little confusing, because we need to know much more about how a fixed star helps us to find the angle. So to get more knowledge about fixed star, just imagine the example which I discussed. When we are traveling in a car, if we are observing far away objects, so the far away objects will move with less change in position with respect to us, or they appears to do not move. So this statement is correct. When you are looking from the car, the mountain which is far away, so the mountain, it appears to not to move. So that help us to find the parallax angle. By using parallax angle, we can locate the diameter of the moon. The same method we can follow to find out the distance from the earth to moon, or earth to any planet, or earth to nearby stars. Okay, so this method having certain limitations. Suppose if you want to find the star which is the edge of the galaxy, so this method it won't work. So for that we will use different methods, another methods. So right now that method not necessary for us. So get the proper knowledge of parallax method.